Welcome to an episode of Blinded by Science, starring Neva and Maddie here.
Yeah!
Hey Maddie, isn't there one law that we haven't talked about yet?
You are right! And we are going to prove Gay-Lussac's law that temperature and pressure influence each other by using these airbags, and we're going to put them in the freezer. Yeah! Alright, so it should be that if we put this plastic bag in the freezer, the temperature should decrease. So the particles will not move as fast, so they will not hit the side of this plastic bag as much, decreasing the pressure. Let's try it. Fire in the hole! Alright, let's check on this bag. Oh, and Miss Biscuit. Well, if you look, the bag, after being in the freezer, is more squishy. If you compare this bag, which has been in the freezer, this bag, which is kept at room temperature, this is far more squishy, while this is far more taut. But, as you can see, as it's being left out in room temperature, it's becoming more and more taut. This is because it went from the freezer to room temperature, which heated up the particles so they're moving faster and pressing against the surface more. This proves Gay-Lussac's law.
And last but not least, we're going to do a mathematical illustration showing Gay-Lussac's law, which is pressure over temperature.
Okay, so when we put the airbags into the freezer, we started off with a pressure of 2 psi and a temperature of 70 degrees Fahrenheit. But then, once we put it in the freezer, the pressure we don't know, so we're going to figure out, and the temperature was 32 degrees Fahrenheit. So, to change the initial pressure from 2 psi into ATMs, we multiply by 0.0680459639 to get 0.136 ATM. And then to transfer from 70 degrees Fahrenheit, we subtract 32 and multiply by 5/9, which gives us 21.11 degrees Celsius, and then we add 273, which gives us 294.11 K. And then, to go from 32 degrees Fahrenheit into Kelvin, we subtract 32 and we multiply by 5/9, which of course gets us 0 degrees Celsius, and we add 273, which gets us 273 Kelvin.
So now since we got all the units, we're going to put it into the formula. Yay! Okay, so we know that we had 1.36 atoms of pressure initially.
Atmospheres.
Yes, atmospheres. My correction. We had 294.11 Kelvin. And we don't know what our pressure is, but we know that we have 273 kelvins for our final pressure. Final temperature.
Right.
Okay. So to do that, we have to multiply on both sides by 273 to find our final pressure. So once we did that, we got pressure equals 0.126 atmospheres. So you can tell that the pressure did decrease from 0.136 atmospheres to 0.126 atmospheres. And this concludes Gay-Lussac's law. Yay!
So, Neva, it's another job well done in the realm of science.
Exactly, Maddie. But what did Miss Biscuit have to do with this?
But I thought you knew.
Do-do-do.